Hi everyone, in today's video we are going to be solving LeetCode problem number 153 called as find mean minimum in rotated sorted array. This is LeetCode medium problem. If you're new here, then I am Radhika. Welcome to my YouTube channel DataZard. Here I solve a LeetCode problem every Wednesday. And now without further ado, let's get started. The question says, suppose an array of length n sorted in ascending order is rotated between 1 and n times. What does this mean? Let's first understand that. So suppose we have this array 0, 1, 2 and 3. Suppose we rotate it one time. When we do that, then this would mean 3 will take position of 0, 0 will move to here, and all of these will move 1 to the right. So the final answer for one time rotation would be 3, then 0, then 1 and then 2. If we rotate it 2 times, then this 3 will go over here because we have already moved it one time. So from here we can say this 3 will go over here and 2 will take 3's place. So the answer would be 2, 3, 0, 1. So in this way we are rotating it, and we can rotate it n times. And this is how they have explained how these rotations would happen, and I've explained this over here. Now, given the sorted rotated array nums of unique elements, there cannot be repeated elements, so we know the elements would be unique. Return the minimum element of this array. So from this array, we have to return minimum element. So the minimum element here would be equal to 0, and this is our answer that we need to return. Now there is one condition that is given in the question, and it is you must write an algorithm that runs in O log n time. Remember that this is what we have to do. Now let us try to take an example and understand it. Now this is my nums array 4, 5, 6, 7, 0, 1, 2. And above that I have written the indexes. So these are my indexes. Now we know that from scanning this is our answer. 0 is our answer because this is the minimum element in this array. So we have to return 0. Now, if we talk about the very simplest way, then what we can do is we can scan this array and store the minimum value. So let's say I'm creating a variable minimum value, and for the first time I'm storing this 4 because there is no other minimum value, and then I will keep going on. So I will move to next location. Is 5 less than 4? No, it is not. So I'll move to the next location. Is 6 less than 4? It is not. Is 7 less than 4? It is not. Is 0 less than 4? Yes, it is. So I'm going to update this minimum value to 0. Then we move to the next one, which is 1. Is it less than 0? No, it is not. Then we move to the next location. It is 2. Is it less than 0? It is not. So our final answer is 0. But when we try to do this, then we will end up with O of n complexity solution. But in the question it says that we have to do this in O log n time. So this solution will not work. Now whenever you hear terms sorted array, O log n time, and you have to search in this sorted array, then one thing that should come in your mind is binary search. This is the most efficient algorithm to solve these kinds of problems, and binary search has O log n complexity as well. So we're going to implement binary search to find answer to this question. If you don't know what binary search is, so in binary search, instead of searching in the full entire array, we divide this array into two halves and only search in left or right half depending on what our condition is. So here we have to define a few values. First would be a left value, another would be a right value, and then we have to define a midpoint as well, and that midpoint is equal to left plus right divided by 2, and we just take the integer part of it. So for us, the midpoint would be left is 0. These left and right, they are indexes. So left is 0 plus right is at index 6 divided by 2, which is equal to 3. So our midpoint is somewhere here. Now, when we do binary search, we have to check in which half do we need to go to. So we're going to use this midpoint for that check. So if our nums of mid is greater than or equal to nums of right, when our value at midpoint is greater than that on the right, what would this mean? This would mean that our minimum point would be on the right side. Why? Because if you look at this example over here, when we were shifting, then we were bringing bigger values on the left side and smaller values were going on the right. So if we find in our example that bigger value is at mid position and smaller value is at this location, which means the minimum point would also be lying within this range. So that's why we're going to look for our minimum point in this range, and we don't have to look for values over here which are on the left of mid. Now to look for that, what I'm doing over here is I'm just going to update my left to mid plus 1 so that I only search in this area. So now I will move my left to this. Let me remove this. I'm moving my left to mid plus 1, and now I have to update my midpoint as well. So for midpoint, I'm again going to use this calculation. So currently our mid left is 4, our right is 6, divide by 2. This is 10 divided by 2, which is equal to 5. So our midpoint is somewhere over here. Now again we check whether our nums of mid, which is 1, is greater than or equal to nums of right, which is 2. No, it is smaller. This condition is coming out as false. So when it is false, when this is true, then we go here. When it is false, then what does this mean? This means that our minimum would be on the left side of this value, because we have not found this pivotal point where the rotation happened. This pivotal point is to the left of our array. So in this case, we are going to update our right. Earlier we were updating our left because we had to search in the right direction, but now we have to search on the left of this mid, so we have to update our right. So I'm going to remove midpoint and my right would point to this location. Now again we have to calculate our midpoint. So I'm going to again use this formula. So our left is 4, our right is 5, divide by 2, which is equal to 9 by 2, which is equal to 4, because we are just taking the integer part. Now again I have my midpoint over here. Again I'm going to check whether this nums of mid, which is 0, is greater than or equal to nums of right. It is less than nums of right. This condition is coming out as false. Mid is not greater than, it is less than what is there on the right. So in this case I have to search on the left side. When I have to search on the left side, then I have to update. When it is false, then we have to follow this condition. So because it is false, we will move our right to mid location. Now our right will come over here. So right and left, they are both pointing at the same location. Now when our left and right, they become equal, we have to stop because we have found our minimum point. So the condition to stop is when left less than right becomes false. When this becomes false, then we say we just have to stop. And in this case, this is becoming false. Our left and right, they both are equal. Because they both are equal, we have stopped. And when we stop, whatever is on the left of nums at this index, that would be our minimum point, and we know that this is our answer. So essentially what we were doing is, we first got the midpoint as this 7. This 7 was initially our midpoint, and we knew that our minimum point lies on this side. Then we again divided this array into half. So this was our midpoint, and then again we saw that our minimum was on this side, and then that's how we got the answer. So we keep on dividing our array into 2 halves and then check whether our midpoint would lie on the left side or on the right side depending on this condition. And we make updates like this. Let's try to understand this using code as well. I will start by defining first left variable and initialize it at 0. So the first index, then right, which is at the last index of this nums array. So length of nums -1. Why -1? Because the indexing for nums, which is the list in Python, starts at 0. So that's why right should be equal to length of nums -1 to compensate for that 0. Then while left is less than right, because I mentioned at the last of my explanation that our condition till when we should be running this loop to update mid value and check for nums of mid is greater than or equal to nums of right is till our left is less than right, because that's when we know when this condition becomes false, we have exhausted all the different halves that can be found in the array. So now when left is less than right, then we do mid. First find the mid. So mid would be equal to the integer of left plus right divide by 2. So whatever is the integer part of this division, that would be our index for mid. And then we check if left is less than right and nums of mid, this is the condition that I used in my explanation, is greater than or equal to nums at right. If this is true, then this would mean that our minimum is on the right side of this midpoint, and because it is on the right side of this midpoint, we have to update our left index. So left would be equal to mid plus 1, because we're going to start from the next location after mid. And otherwise we are going to check if left is less than right and nums of mid is less than or equal to nums of right. So if the opposite condition is true, then we would say right should be equal to mid, because we know that our minimum is on the left side, and because it is on the left side, we have to update our right location to whatever is on the mid so that we search in that half. And now at the end, all we are going to do is we're just going to return whatever is on the nums of left, because that point is the minimum point. Now I'm just going to submit this. I have to return over here. My return statement was inside the loop, that's why it came out incorrectly. Now I will submit it again. And you can see that all our test cases are passed, and this is the solution that gets accepted in LeetCode. Now let us quickly do a dry run of this code. So I'm just going to copy this solution and paste it in my whiteboard. Now I'm taking the same example as I did before, and let's dry run this code. So I'm going to initialize left at 0 using this. Then right will be equal to nums of length 1, 2, 3, 4, 5, 6, 7. So 7 minus 1, because length of nums is 7, minus 1 will be equal to 6. So my left will be equal to here and my right will be equal to here. Now we enter this loop. So iteration 1. For iteration 1, we first check whether left is less than right. Left is 0, right is 6. Yes, that is true. Then we have to update our mid. So we update our mid. That would be equal to left plus right divide by 2. That is equal to 3. We only take the integer part. So our mid would be equal to somewhere over here. Now we check if left is less than right. Yes, that is true. Left is less than right. And nums of mid is greater than or equal to nums of right. Nums of mid is 7, greater than or equal to nums of right, which is true. Yes, that is true. 7 is greater than 2, which means we have to update our left. So in first iteration, we are updating our left, and that would be equal to mid plus 1. So mid is 3 plus 1, that is equal to 4. We're going to shift our left over here. This completes our first iteration. Now we are entering second iteration. So in iteration 2, we again check whether left is less than right. Left is 4, right is 6. Yes, that is true. So we get the mid value. So our mid would be equal to left is 4 plus right is 6, divide by 2, take the integer part, which is equal to 5. So our mid would be equal to 5 and we're going to point that mid over here. Now again we check if left is less than right. Yes, that is true. And nums of mid, which is equal to 1, is greater than or equal to nums of right, which is equal to 2. Is 1 greater than 2? That's false. But this condition becomes true, this elif condition, which means we have to update our right. So now our right would be equal to mid. Mid is currently at 5. So our right would point to 5. So right will go over here. And now we enter third iteration. I'll just write that over here. So iteration number 3. Now again we first check whether left is less than right. Left is at 4, right is at 5. Yes, that is true. In this case we have to update our mid. So mid is left plus right divided by 2, which is equal to 4. So our mid would point at 4. Now we have to check these conditions. If left is less than right, yes, that is true. Left is 4, right is 5. We check if nums of mid, which is equal to 0, is greater than or equal to nums of right, which is equal to 1. No, that is false. 0 is less than 1. So which means this condition is evaluating to true, which means we have to update our right because our minimum is on the left side of the array or list. So we have to update our right in this case. So right would be equal to the midpoint, which is equal to 4. Now this completes the loop. Now for the next loop, we have iteration 5. For next iteration, our right is coming over here as well because we have updated our right. So in this case, is our left right? No, it is not. They are both equal. So we just stop over here. And when we stop, whatever is on nums of left, that would be our answer. So on nums of left, we have 0. So this becomes our answer. So the algorithm would be, first you divide the list into 2 different halves, and then we have to decide whether we have to look into the left half or right half. So for that, we are going to check for this condition. If whatever is the value on the middle index is greater than or equal to the index value on right index, if this is true, then it would mean that our minimum is lying on the right half. And because it is lying on the right half, we will have to update our left value. So left value would be equal to mid plus 1 because we have evaluated till mid and we know that it is not found till middle index. But if this condition comes out to be false, then in that case, we know that our minimum value will lie on the left half. And because it is on the left half, we will have to update our right. So right would be equal to mid. Now the stopping condition would be when our left is less than right condition becomes false. Because when it becomes false, we have evaluated all the different halves that are possible in the list, and whatever is there on the left of nums, that would be our answer, or that would be our minimum value. Please let me know if this video was helpful or what LeetCode problem should I solve next in the comments below. Thank you for watching. I will see you in my next one.